Okay, we're going to go over the Geometry Chapter 8 review for Friday's test. You should have your work done on lined paper. There's just not enough room on this document. And then we'll staple it and turn it all in. When your test, when you come in for your test tomorrow on Friday the 2nd, you're going to turn in any later missing work. You're going to turn in your notes packet and this chapter review work. Later missing work, anything from chapter 8 you need to get me, and then you're also gonna staple and turn in your chapter 8 review, this set of work. I want you to hang on to it overnight so you can use it to study from. All right, first of all, section 8.1. You had all day in class to work on this. We had a guest teacher yesterday. Hopefully I can get anything questions you had cleared up for you. For number 1, find the scale factor, list all pairs of congruent angles, write the ratio of corresponding side lengths in a statement of proportionality. Now, first thing that I want to do, congruent angles. I like to do it by the names. When they tell me the names, A, B, C, D, that rectangle is similar to E, F, G, H. I'm going to match up angle pairs first. Angle A and angle E. And again, I just do this by the order of the letters. Angle B is the second letter in the name. Angle F will be the second letter in the other one. Angle C and angle D. And if you notice, oh, that's not D, it should be G. C and G. And if you noticed, D and H. There's a lot of things going on in the question. I haven't found the scale factor yet. I've got all the congruent angles. There's 3 things going on in this question. Write the ratios of corresponding side lengths in a statement of proportionality. Well, I'm going to do that by the names here as well. And while I do it, I'm just going to code my picture. Segment, now this pre-image, or pre-images are always on the left, images on the right. So my image lengths have to be in the numerator. I'm going to start by putting my AB in the denominator, and going along with AB is going to be EF, AB, EF. The only thing you could have reversed is the letters, but you have to have this pair together. Then we're going to put BC is going to go with FG. And if you haven't color-coded that on your drawing, you could do that right now while you're just checking your work. I'm just over here color-coding mine. Then I've got BC, CD, goes along with GH. I'm going to get that color-coded. And then DA, let's see, my CD, GH. And then I've got my DA or AD over EH. Now, the reason I chose to do that first is because now I can go in and match up numbers that correspond to each other to find that scale factor K. And so then the scale factor K, let's see, what do I have? Let me do the 9 over 12, the purple ones. K is equal to 9/12. If I put that in my calculator and pull a math frac, that reduces to 3/4. So again, these problems have a lot going on, 1 and 2. You've got to have the angle pairs, side lengths, and a ratio statement of proportionality, and figure out what that K is. And I'm going to tackle number 2 slightly different. I'm just going to go match up my colors right now. Right angle to here. Here we go. A little bit easier with 3 sides to see what goes with what. And I could go right back to the names. Using the names, I'm going to put this picture aside now that I have it for myself. Number 2, triangle XYZ, similar to triangle RPQ. Angle X, well, that's not angle X. Angle X and angle R. Angle Y and angle P. Angle Z and angle Q. Now, somebody watching this might be like, oh my gosh, that woman works really fast. Well, the fact of the matter is you had all day yesterday, and you should have all your attempts with you. So, XY, this needs to be quick. My pre-image is on the left. I'm going to put my side lengths from the pre-image on the bottom of my fractions. Image over pre-image, always. It would change your scale factor if you don't do it the same way every time. Let's see, XY and RP. Wow, I still am finding myself go back to the name even though my colors are there. YZ and PQ, yep, my colors match. And ZX and QR, yep, my colors all match. Now, there's my statement of proportionality. Last but not least, I should be looking at a scale factor. It's going to be a number smaller than 1 because I can tell it's a reduction. I'm going to use my my green, my Y, my ZX over QR is where I'm going to set this up. Now you can set it up from any of these pairs. You should still get the same number. So what did I say? My ZX. I flipped this one. Glad I went to that one. I flipped it. QR should be up top. ZX should be in the bottom. Well, there we go. Glad I caught that. ZX. 20 is in the bottom. 8 is in the top. When I reduce that, 4/10, 2/5. Scale factor for number 2 is 2/5. And again, watch for questions like that on your test because there was 3 parts in those questions. Make sure you're doing all the parts. In number 3, two similar triangles, they tell us it has a scale factor of 3 to 5. It's written as a ratio with a colon. We can just write it as a fraction. The altitude of the larger triangle, now all that the altitude is just kind of the height of the triangle. So that would be what our altitude is, just to get an image. The altitude of the larger triangle is 24 inches. What's the altitude of the smaller triangle? Well, I'm going to use my scale factor to set up a ratio, and clearly the larger triangle's on the bottom. It's got the larger scale factor. I'm going to put a 24 there, and an X or an A for my missing altitude up top. Now when I cross multiply in here, 3 times 24 is 72, if I remember right. Yeah. And then that's going to be equal to 5 X's. And 72 divided by 5 is going to leave me with the missing altitude of 14.4. What were we measuring in here? It's in inches. 14.4 inches for number 3. Now moving on to number 4. I like number 4. It gets into that scale factor, how it's related for perimeters and areas. Remember, if our scale factor is K, perimeters have the same relationship, and areas will be related by K squared. Perimeters by K, areas by K squared. The reason why that's important is in 4, two similar triangles have a pair of corresponding sides of length 12 meters and 8 meters. I'm going to assume then that the 12 is my pre-image, 12 to 8. When I look at these corresponding side lengths, that's defining what my K is. This is going to be 2/3. The larger triangle has a perimeter of 48 meters and an area of 180 square meters. Find the perimeter and area of the smaller. All right, in terms of perimeters, for perimeters, I'm going to use my 2/3 is equal to, what did we have? The larger triangle has a perimeter of 48. I'm going to use a little p up here for the perimeter of the smaller. 3 times p will be equal to 2 times 48, which is 96. And then when I go and divide 96 by 3, I find out that the perimeter of the smaller one is 32. Perimeter of smaller is 32, and this is meters. Now, they want us to find the area of the larger. Now, the area has to be related as K squared. So I literally need to square my 2 and my 3 and my scale factor. That's going to turn into 4/9. So to relate the areas then, I have to say, all right, 4/9 is the area relationship. The area of the larger one is 180. I'm going to use a little a for the area of the smaller one. I'm going to multiply 4 times 180. And 9 times a, 4 times 180 is 720. When I divide that by 9, I find out that the area of the larger one, I'm sorry, it'd be the smaller one, is 80 square meters. So a little tricky, but you can handle it. Lots going on in 1 through 4, that section 8.1 work. Section 8.2, proving triangle similarity by AA. In number 5, I'm looking to talk about number 5 in terms of giving an A pair of angles that are congruent and another pair of angles that are congruent. What I can see here in 5 is that the measure of angle Q is 35. The measure of angle T is 35. So clearly angle T is congruent to angle Q. That was given to us on the drawing. I'm going to literally say given to us. Then I want to talk about the vertical angles that are going on at S, because I know that vertical angles are congruent to each other. So my second pair of angles is going to be, what do I have? QSR. Angle QSR is congruent to angle TSU. Angle TSU. As those are vertical angles. There's my AA. One pair of angles, another pair of angles. So what I'm going to say, vertical angles. by AA, triangle RSQ is similar to triangle UST. Make sure you recall your similar notation and use it. Now, number 6, we've got some givens in here that are going to help our life out a little bit. When we go and take 180 minus 90 minus 60, that tells us that angle B is 30 degrees. In the other triangle, if I take 180 minus 90 minus 30, it tells me angle D is 60 degrees. And so in this one, actually, you just need to have 2 pairs of angles, but you've got 3 options for the pairs of angles. We can talk about angle C being 90 degrees and angle F being 90 degrees. So angle C is congruent to angle F, and those guys were given that they were 90 degrees. And then we know that angle A is equal to 60, which is equal to, I'm going to do this a little bit different here, which is equal to angle D. That's given to us, and actually if we needed to, we could go on and talk about angle B is equal to angle E. Those are both equal to 30. Those are given to us. We had to use the relationship of 180 minus the givens, but we had it. And then we're going to go on and say by AA, triangle ABC is similar to triangle DFE. Now I'm going to have to draw a picture for this next one. I'm going to do that on my paper here. In number 7, there is a similar problem like this on your test. A cell phone tower, here's going to be our cell tower, casts a shadow that is 72 feet long. So the cell phone's throwing a shadow, and this shadow is going to be 72 feet. I'm going to assume that the shadow, so here's my tower, cell phone services, that's kind of funny. There's a tree nearby that is 27 feet tall. Here's the tree right in here. That's 27 feet tall, and it casts a shadow that is 6 feet long. So this little piece right here is 6 feet. Now, the question is, how tall is the tower? Well, we've just created a pair of similar triangles here because we're going to assume that the tower and the tree are parallel to each other. And if that's the fact, and I need to know what the tower's height is, let me put an X on the tower. The height of the tower is related to the height of the tree, the same as the length of the shadow is related to the length of the shadow of the tower is related to the shadow of the tree. Again, the height of the tower is related to the height of the tree. These are the heights, and these are the shadow lengths, as the shadow is related to the shadow length of the tower is related to the shadow length of the tree. I'm going to go and multiply my 27 by 72. I divided it, try times, and I'm getting 1944. And when I divide that by 6, I find out that the tree is 324. We were measuring in feet tall. Here's number 7 for you. Let's see. We go on to 8.3. I'm going to stop this video here and I'll pick up 8.3 in a new one.